Okay, I am doing the problem for the expert TA homework, problem 4, and it says, suppose the soccer player boots the ball from a distance of 26 meters into the goal. Find the initial speed of the ball if it just passes over the goal 2.4 meters above the ground, given the initial direction to be 40 degrees above the horizontal. So right here, we have the soccer player that kicks, which is at the ground level of 0, which is right here, meters, initially with an angle of 40 degrees, which we have right here. And the goal is 26 meters. And the ball barely passes over the goal, which he kicks over here, passed at 2.4 meters in the air. So what we want to do is we want to find the initial speed, which is v naught right here. So first thing we need to do is find the expression for the initial velocity in the x direction, which is right here. And that is v naught x equals v naught cosine theta. And here v naught x stands for x component of velocity, and v naught stands for initial speed, which was right here. Next, we have to write the expression for the displacement along the x direction, which will give you x minus x naught equals v naught x times t. Here, t is time taken, v naught x stands for x component of velocity, and x minus x naught stands for displacement along the x direction. So now we have to substitute v naught cosine theta for v naught x. And once we do that, it's x minus x naught equals v naught cosine theta times t. Then once we do that, we have to divide both sides by v naught cosine theta to get t. And t will equal x minus x naught over v naught cosine theta. Once we do that, we have to write the expression for the initial velocity in y direction. And it's almost the same as the v, but v naught y equals v naught sine theta. I'm sorry, my x looks a little bit like a y. It's supposed to be a y, so that's why it looks a little confusing. But that's supposed to be v naught y equals v naught sine theta. And once that is, here v naught y stands for y component of velocity, and v naught stands for initial speed. Then we will write the displacement along the y direction. So then y minus y naught equals y naught y t minus 1/2 gt squared. And the square is because there is a force acting on the ball. So this is why we have the gt squared. Once we do that, we substitute v naught sine theta for v naught y, then, and x minus x naught over v naught cosine theta for t. So once we substitute that for t, the equation becomes y minus y naught equals parentheses v naught sine theta times x minus x naught over v naught cosine theta minus 1/2 g times x minus x naught over v naught cosine theta squared. And all we did was substitute the t and put that in for the equation, the v naught cosine theta. And then we're just going to flip this over. Once we do that, we have to rearrange the equation in terms of V naught. And that gives you V naught square root, then we have 1/2 G x minus x naught squared over cosine squared theta times y minus y naught minus x naught tangent theta. And how we got tangent is when you do sine over cosine, it gives you tangent. So then once we do that, we have to substitute our numbers into the equation. So 9.80 meters per second squared for G, which is our gravity, and 26 meters for x minus x naught. And then we have 40 for theta and 2.4 meters for y minus y naught. And then this gives you the equation right here where we have V naught. We have the 0.5, which was 1/2, and then we have the 9.8 meters per second squared. Then we have 26 meters squared. We have our cosine 40. Then we have our 2.4 minus 26 meters, then tangent 40. And that should give you, when you put in the calculator, it should give you the initial speed of 17.6.